Hello, my name is Edwin from Scalable, and I'm presenting the LibreS3 application, mainly some ideas about its design and some issues I encountered with packaging and debugging. First, let me introduce some concepts that would make it easier to understand what my poster is about. I won't cover monads because they're already quite extensively discussed today. One important concept is an S3 server, called after the proprietary Amazon Cloud S3 service. And there are already free and open source replacements for this object storage service, and our LibreS3 is one of them. So what is Amazon S3 server? It allows you to store and retrieve files both from inside and outside the Amazon Cloud, as long as you provide the correct authentication data. So in this context, we have LibreS3, our application, and some existing clients written in different languages, S3 CMD, Boto, or other S3 clients that are talking with our application using the S3 protocol. And on the other side, we have a cluster built from another open source project called SX, which allows you to run your own private cloud with distributed data storage. So LibreS3 is in fact an application that allows you to move your existing S3 applications from the Amazon Cloud to a private cloud that runs on your own infrastructure. The architecture of LibreS3 is not novel. I try to follow the existing practices, and in fact in some situations it's quite similar to HTTP and Mirage. The main principle is that I don't want to choose at the very beginning what library or what framework I use. I want to leave that at the very end. So in this sense, most of the application becomes functorized. We also have to be careful with acquiring resources, especially that we deal with network I/O and disk I/O. So I use this concept from the batteries library that we grab all accesses to resources with a function that acquires the resource, runs the function, and releases the resource. Now, of course, most of the code in LibreS3 is quite specific to it, but still some of it could be generalized, so it could be used in other projects as well. In this case, I just have two small examples, AnyCache and AnyHTTP. AnyCache is a least recently used cache with two queries, very similar to what's used in PostgreSQL and OpenBSD. You have effectively two queries, main cache that stores the often really used keys, and an input cache that stores the newly used keys. And then we have a victim cache that stores everything that didn't fit in the first two, and in this case I used a fixed-sized weak array. Again, this interface is functorized, so you can use either direct style immediately executed code or monadic concurrency library. What's somewhat different is that the unit tests themselves a single functor that you can instantiate with all the supported monadic libraries to make testing easier. AnyHTTP is just like a SYN wrapper around HTTP to allow use directly your application either with LWRT and HTTP, async and HTTP, or LWRT and Oxygen server. And the main goal would be to allow you to write REST application independent of the actual HTTP implementation. And this might also have a benefit in testing the compatibility between the existing HTTP implementations. And finally, my poster also describes some issues that I encountered while developing this code in OCaml. I have to thank the upstream maintainers for their good collaborations regarding accepting patches. In this sense, one interesting bug was the double release of the OCaml runtime lock, for which I wrote a debug patch to the thread runtime. This is currently on Mantis, but given the work on OCaml multicore, it probably should wait until a later time. And Some other examples of interesting bugs are using Unix fork instead of LWT. Unix fork, which can cause your application to hang in interesting ways. And of course, there were some missing features that needed to be added to Oxygen Server, for example, to fully support REST API. One issue that remains undecided is how to make debugging monadic code easier, because just relying on stack traces is not very useful because you have very many tail calls and just the stack traces aren't very meaningful in this sense. The last problem is packaging, and in this sense I've seen some good progress today on earlier talks. My main problem was the lack of OCaml to RPM or OCaml to Debian tools, and I would hope to see some progress in this area.
We have those now.
You have it?
Yeah, 2 days ago. The OCaml 1.2 has Red Hat packages.
And the other problem was building some kind of portable binaries or binaries for each distribution. I made some early attempts with the Linux standard-based SDK and the Musel libc, but they both had the drawbacks that you actually needed to build all your dependencies, so including OpenSSL, and that's something I really don't want to do, to build and ship my own OpenSSL binaries. So in summary, I present a free and open source implementation of the S3 protocol in OCaml, some libraries that could be reused for other projects, and I'll be interested in discussions around the library design and the bugs and packaging issues I've encountered. And as future work, I'd also like to convert some of the JSON and XML parsing code in LibreS3 to use some combinators. In that case, there are 2 candidates already, cconv and metaconv, that could be used to make this easier. And finally, all the poster, the paper, and the slides are available at that URL that you can also find on the poster. Thank you.